back to the DataStack Show. Today we are going to talk about a really interesting topic, and it's ROI related to all of the data workloads that you run. Kostas, I know that you have questions about what the definition of workload is. We want to dig into that. But we're going to talk with Vinoo from Bluesky. And what I'm really interested in is on their website, they say, if you're spending $50,000 or more on your Snowflake bill, you should talk to us because we can help you drive better ROI, which is fascinating. So I want to know about that number. I also want to know about their relationship with Snowflake, right? Because reducing your Snowflake bill, like, are they friendly with Snowflake? So that'll be interesting. So I have so many questions to ask. And then, of course, what does the product do? But how about you?
Yeah, I mean, it's a lot difficult, like to spend like 50 grand on Snowflake, right? So,
Right.
you know how easy it is. So yeah, it's going to be like very interesting to hear like war stories. Let's say like what's the experience with our customers. I definitely would like to chat about like the definition of workloads and what they see out there, like in terms of what is the most expensive part of like the operations around data. Yeah, also like the other thing, which I think is going to be like quite interesting is I know that right now like the product is focusing on Snowflake, but what it means like to take this kind of product, this kind of service, and like deploy it like on different data warehouses or data lakes or data infrastructure in general. So I think it's going to be like a very interesting conversation. There's a lot of discussion lately about like the cost of Snowflake. So I think it's the right timing to have this conversation today.
I agree. Well, let's dive in and talk to Vinoo.
Yeah.
All right, outro. My takeaway from this, Kostas, there were a lot. I loved the car analogy. I obviously dug into that multiple times, but I think it was really helpful to hear someone so technical mention how difficult it is to actually get a sales contract, from initial conversation to, sort of signature. And I just really appreciated that. It was funny because Vinoo is obviously a brilliant, person to even be able to perform all of those job functions. I mean, not only is he brilliant from sort of an engineering and data perspective, but interpersonally, obviously, to be able to actually like be a salesperson too, is a whole different skill set. So I think that's a really rare combination. But it was just really enjoyable to hear, sort of hear it from the other side, to hear an engineer say like, I mean, it is so hard, to actually like get a sales contract through, right? Yeah. Whereas on the other side, it's like, you don't understand how difficult it is to like, scale a distributed system, or, whatever it is. So that was my big takeaway, along with all the other great stuff, but that just made me smile.
Yeah. Like I think what I really enjoyed from the conversation is the definition of like the workload as capital allocation. I think that was like very, very interesting to hear and very refreshing. And in general, like this whole like mental model of like how to think about your data infrastructure and how it is utilized and how you can optimize it and what optimization means at the end. I think that was like probably the most valuable part of the conversation, at least for me, and hopefully like for many of our like listeners out there who sooner or later they will face the need to optimize also for cost and not just like for performance or SLAs in terms of latency and stuff like that. So yeah, we probably need another episode with him. There are more like stuff to discuss and get like in more detail, like technical detail on the solutions that they have. So I'm looking forward like to have him on the show again in the future.
Absolutely. Well, thank you so much for listening. Subscribe if you haven't, tell a friend about the show, and we will catch you on the next one. Vinoo, welcome to the DataStack Show. We are super excited to chat today.
Thank you, Eric. Very excited to be here.
All right, well, give us your background. You've done some really interesting things in some really interesting industries. So tell us about your background and then what led you to Bluesky.
Absolutely. I started my career off at Palantir, was there for almost 7 years. I did virtually every job you can imagine, from software engineer, building some of our core distributed systems, to like salesperson selling our product, to deploying it in commercial, healthcare, military environments, before eventually leading our like core compute team. So every bit or byte of data that flowed through Palantir flowed through my team at one point. After Palantir, I realized that we had built these incredibly powerful analytical tools, but a lot of our customers and a lot of just analytics tools consumers didn't have the data size or scale to warrant the power of these tools. So I decided to focus on that area and built a data as a service company called Veriset. I think it's about like 15 million ARR now, still chugging along.
Oh, cool.
Really focused. Thanks. Yeah, still doing well. Really focus on how do we take huge amounts of data, make it accessible, make that data accessible to consumers who don't have to do these crazy expensive cleaning operations. After that, an old friend from Palantir reached out and ended up joining Citadel, the hedge fund, leading business engineering on Ashlar Capital. So building all the tools, technologies, managing the data engineering team for the last mile aspect of portfolio managers, alpha generation processes, just trying to make help people make money effectively. Before, actually, and I guess right after, another mutual friend made an introduction and got introduced to Bluesky. And Bluesky, where I am right now, I'm on the founding team. Our goal is really to provide an optimization mechanism and a mechanism for people to introspect their own query workloads and their own data cloud workloads, and really get like the maximum ROI of their data cloud. And that means works in a number of dimensions.
Awesome. Okay, I have a question about your time at Palantir, because the spectrum of job titles that you mentioned is astounding in many ways, right? You just rarely ever hear of someone who, sort of goes from software engineering to sales, to sort of, owning the data platform. And it sounds like multiple jobs in between. I would just love to know, having that breadth of perspective inside of a single organization, what was some of the most interesting things or unexpected things that you learned doing such drastically different roles?
Absolutely. I think this is one of the things that Palantir does best, where it's almost like you can have 10 different jobs just in the same umbrella company. So first and foremost, the reason that I ended up like forward deploying, as they would call it, is a lot of the design decisions that I guess mine and my code engineers made on some of the early data storage products were not always optimal. And until we had the real customer like workloads, and I'm using workloads again, but like workload and understanding, there was no way we could have designed a system that actually made sense. So I think the first big and surprising thing was truly how different, anyone who's worked in production software will know this, but how different production versus development is. So really just understanding how we build software, how we actually develop a user focus, especially when the tools and technologies aren't directly like consumer facing. Like a distributed system or a data storage system, you wouldn't think of as being particularly customer facing, but all the decisions that you make from a design perspective, from everything from compliance to storage, all directly affect the user experience. The second thing is really almost the value of having a technical slant, not necessarily in your sales cycle, but amending your sales cycle. So being able to actually communicate with the people procuring your software with a deeper understanding of why things are implemented the way they are, some of the challenges and limitations, I think all gave me a lot of respect for like the engineering background that I had, and conversely, going back to the engineering side, really understanding how hard it is to move a contract from a initial POC to an enterprise agreement. It's just so difficult.
Yeah. Yeah, that's great. I'm glad you brought that up because I was going to ask you from the engineering side, a lot of our listeners are technical. And so, that's really helpful to hear that perspective on the sales side, right? Because I'm sure, for salespeople, building production software probably seems really, really hard, right? Moving a contract is difficult too. Okay, well, I know Kostas has a bunch of questions, but I actually want to start with a really specific data point that you list on the Bluesky website. And I think this will be just a great jumping off point. So I know that ROI means that there are multiple vectors to ROI, right? But a big one is cost. And when we think about data infrastructure and the term workloads, which I know we want to dive into, ultimately it kind of boils down to, what is it producing versus what does it cost you, right? And so on your website, you list a number spending $50,000 annually on Snowflake, which is interestingly specific. And I'm a marketer, so, it stuck out to me and got my attention for those reasons alone. But I'd love to know why that specific breakpoint and what does that number, whether or not it's the perfect number for as a proxy for, what Bluesky helps solve. What is represented underneath that? And I think specifically, I'd love to know, like, how can we help our listeners sort of benchmark cost even?
Absolutely. So I will say transparently, the 50K number was kind of a number that was just picked. However, it's one of those like a backronym where we pick the number and then realize, wow, this is actually indicative of something pretty powerful. I think what's been really interesting, especially with something like the Snowflake ecosystem, is starting off as a small scale user. I mean, Snowflake's an incredibly powerful tool. SQL is really easy to write. There's all these built-in integrations, which is a blessing and a curse. But the number one thing that I've heard from our Snowflake customers is the speed at which you can ramp up your Snowflake spend by actually doing things that add business value is unparalleled. So you deploying like a Sigma or like a DBT, these are incredibly powerful technologies and tools, but they almost add this exponential growth aspect to your Snowflake spend. And so that number in particular, I think it almost is the beginning, almost the precipice of, I'm now going to become a heavy Snowflake spender or heavy Snowflake user. And so Bluesky has customers and partners that go anywhere from like, that 50K number up to the double-digit millions for Snowflake spend. And so where you are on that data journey or that data process, and when you actually decide to engage us, tells a lot about how you think about, your utilization of a data cloud. So we picked that number largely because it really does look like the precipice of starting to expand your utilization and your Snowflake footprint.
Super interesting. And one follow-on question to that, and this is probably multiple questions packaged into a single one, but when you think about let's just use the examples that you mentioned, right? So of course, SQL is easy to write. And I mean, it is wonderful that we live in an age where you can, deploy Snowflake, start writing SQL, get a huge amount of value in a really short amount of time. But then when you think about a tool like Sigma or even DBT might be a better example where it sits pretty low, DBT in particular sits pretty low in the stack in terms of like where it interacts with the data, and then sort of pushes value out in a large variety of contexts, right? So you almost have what I would call like ROI fragmentation. So so there's the cost side of it, but then how do you think about ROI in such a fragmented way because it's touching so many parts of the business? That's not necessarily a simple calculation.
Definitely. I think maybe this is the finance side of me, but anytime I think about ROI, I think about really like, am I effectively deploying my capital as a business? And what I mean by that is not necessarily like, am I spending a certain dollar amount, but the dollar amount that I'm spending, am I actually spending that in the most effective way possible? You can kind of think about it in the, I always like using this car analogy. Like if I'm driving around in a car, I can either be very gas efficient or like very bad at consuming gas. I'm slamming the brake or slamming the gas, I'm going to burn through a lot of gas really quickly. Even the car that I use, like whether I'm driving a Hummer around, it's going to be guzzling gas like crazy. So that I'm paying for the gas either way. Does that gas consumption actually add the value that it should to my business? And so when I think about ROI, I don't necessarily just think about, am I getting a dollar value back for this effective cost of compute that I'm putting in? Am I deploying that capital for my business in the most effective way possible? As a concrete example, I think dbt is a super powerful tool, right? Being able to test and almost have like a CI/CD process around SQL is incredibly powerful. Absent something like dbt, you can run a series of failed queries, like one after another, just ranking out more and more cost. Now, the capital deployment of just letting a query run and failing is a horrible way to deploy capital. If I could instead use a tool like dbt and almost get all of that, I mean, dbt has its own costs, but get that failed query capital back and deploy it against another business critical problem, that to me is a much better ROI and a much better deployment of capital.
I
think
that makes sense.
Exactly.
Okay, I'm going to ask one more question, but Kostas, I feel like I've been hogging the mic. Vinoo, could you help us understand? So let's say I'm looking at my Snowflake bill. It's 75 grand. We're starting to have internal discussions around like, okay, we're getting some inquiry about like, wow, this cost is really ramped up. Describe the process of how Bluesky would come in and help us address that situation.
Absolutely. So the first thing is, as any engineers would, we start out with data, right? We want to understand not just like the data of what the bill is, but what actually makes up that bill and why does it look the way that it does? So the first thing that we do is we never need access to any of your business data or anything, other than metadata of your query history. From that, we can actually tell using some proprietary algorithms, first, where is your compute actually going? Like, am I overspeccing my warehouses in Snowflake? Do I have a bunch of idle compute? Do I have these massive queries that take up, thousands of credits after one execution? So we really start with an understanding of what is the information that I have on the ground from Snowflake. From there, we start introspecting. By adding our own kind of flavor and opinions into our product, some of the examples I gave, like warehouse idle credit, or even an ability to look at a query and say, this query is ordered by, this insert is ordered by, this table rather is ordered by a particular column. Consumers of that table should take advantage of that order by and filter where they can. Those are insights that we can display as well. So it starts with the understanding and onboarding of the unique aspects of a data cloud. Then we look forward. So it's really easy to say, okay, well, we're in this position now. Let's just do like a P0 tourniquet cost-cutting exercise, only to end up in the same situation 3 months from now when the spend has grown. So what we instead do is also provide tools and mechanisms for controlling costs from a guardrail perspective as you move forward. And these are ways of coalescing functionally equivalent queries or semantically equivalent queries together to actually attribute a cost, or even highlighting something like a misconfiguration where I've sized a warehouse a particular way when the workload doesn't actually warrant that sizing of the warehouse. So it's a data-driven approach that really starts with visibility before extending into this like insights level of what you can manually change before building Bluesky's end vision, which is an automated tuning and healing layer. Like eventually you're going to get tired of implementing these insights. Maybe just turn on an autopilot and we can figure out what to do for you.
Super interesting. All right. Well, that's a great point on which to hand it off to Kostas. Kostas, thank you for your patience.
Thank you, Eric. Thank you. So, Vinoo, let's chat a little bit about like workloads, right? I mean, people are using data warehouses obviously for analytical purposes, but there are many different things that are happening in a data warehouse before we can get a dashboard or a report or like whatever, right? So can you help me understand, like, how do you define a workload in Bluesky? Yeah, we'll get deeper into that. So let's start with this.
Sounds good. To me, a workload is, in the olden terminology, there's like the OLTP, OLAP, and like, or batch, or, streaming or analytical compute. For me, a workload is really going back to that finance. It is the way I'm deploying my capital in my data cloud. So the workload can involve anything from me writing data, persisting that data, me actually doing Snowflake's like auto clustering behind the scenes, to me repartitioning data, or me even doing things like a reverse ETL process of writing data out of the cluster. So these don't fall into necessarily like batch analytical, or these like clean definitions of what were previously like I'm a batch compute heavy workload. It's much more so how I'm utilizing that compute. That's how I think about the workload.
So what are, like, let's say, some common categories of compute utilization that you see out there?
So first and foremost is, I would have never expected this before Bluesky, although you can kind of guess it's there, but the big ones are really BI, like all the business intelligence tools like Looker, Tableau, Sigma has some of these. There's just such an inundation of wanting to get insights out of my I guess data, my system, that BI actually accounts for a huge amount of the workload. Now, whether or not these dashboards are actually actively used or consumed, they are the ones running these automated queries. The challenge with BI, especially in terms of like a workload perspective, is a BI tool is not working like, let's say, 9 to 5. It will execute its queries whenever it wants. It will do data refreshes at any time. So your heaviest consumers can actually be something like BI tooling. So I think the second is, and I'm going to kind of pick the ones that I think are unique. The second is maintenance. And few people actually think about maintenance in terms of what needs to happen for your data cloud to operate optimally. And these are literally things like Snowflake's repartitioning or reclustering, where I want my data, like I want to partition, I'm using partition and clustering interchangeably here, but I want to cluster my data a certain way. But there are some maintenance operations that need to happen with Snowflake's own compute behind the scenes to actually ensure that I'm able to read tables the way that I want, and the tables look semantically the way I want them to. And so I kind of group that all into maintenance, which is, I think, distinctly separate from like even something like compliance, like CCPA, GDPR. These workloads are the right to delete. I actually group these into a separate type of workload because they involve both this like linear scan, or like taking advantage of some unique file format way of scanning through your data, actually deleting and making incremental changes. So I think these are and then of course you have your analytics, someone going on running a ML job or running some kind of like just one-off SQL query to get a table back. And you have your ETL pipelines that come from a variety of sources as well.
Yeah, it's interesting that you didn't mention ETL as one of like the main workloads out there. Why is that? You don't see like, or you just include it as part of BI? Like, how do you see like ETL being part of the workloads there?
It's a great question. So ETL is always it's kind of the bedrock of like, if I'm using data, there's going to be some cleaning process, some transformation process, some load process, like or extract process. There's all of these kind of live in the same almost ecosystem. But the reason I don't think about ETL as prevalent of a workload is because it actually tends to be the place that people are investing most of their time and energy. It's not the like long tail of, oh, I built this dashboard 2 years ago and forgot about it. It's really like, this is clear business value because every day these tables need to be updated. They need to be transformed. They need to be written to. So deploying capital against ETL jobs is almost an easier justification than deploying it against BI tools that may not have the right consumers or may not generate as much business value.
Makes sense. And Okay, you mentioned like BI maintenance, compliance, BI in terms of like what you've seen out there. I would expect that like BI is like one of these things that it's kind of let's say predictable in a way. Outside of, okay, let's say have like interactive analytics where you obviously you need to sit like on top of your BI tool and start like experimenting with queries and like all that stuff. But when you have like dashboards, you can deploy like quite a few different methodologies like to optimize the process, right? Like materialization, for example, is one of them. Like, okay, how many times do you have, or caching, right? There are tools, and like BI is like one of these processes that has been around for like very long time. So database systems have really like evolved around it, right? But what do you see in happening out there? Because obviously there's a lot of space for optimization from what I understand. So it's like we are missing the right tooling to do that. Is that like why is the reason that there is so much space still for optimization when it comes to BI?
It's a great question. I think in the past, BI fell in this category of like read only, in the sense of I'd have a dashboard, it was executed once, and it would just be, like on a page for someone to consume. In the new world of data applications, like there's a lot of these companies like Streamlit, Houseware, that are doing these really, I think Snowflake actually just acquired Streamlit, doing these really powerful like data application creation. You as a non-technical user, or as a, I don't want to say non-technical, but a less technical user, can now interact with the platform in a way that you previously didn't really interact with it. Not just filtering, but I can actually bring in and join with no code or low code solutions, other tables, and create new derivative data products just from my own system. So the materialized view creation caching, they all solve that root node problem of this, compute happening over and over again and persisting that. But any of the derivative products, even notebooking tools, like Hex, I think is a really cool product as well. You can create all of this derivative value and all of these derivative data products that still kind of live in the realm of BI, although I know people are using Hex for ETL also, but still kind of live in this BI tool, BI world, independent of, I guess, a previous just like an individual dashboard that was just sitting there consuming data with no one really looking at it.
Mm-hmm. And do you feel like we need new tooling to optimize like these new, let's say, I wouldn't say new workloads, but like new facets of like existing like workloads? Like what do you see there? I mean, obviously there is an opportunity, that's why like Bluesky is out there, but what like a database system should do like to account for these new ways of like interacting with data and make like the whole process more performant at the end?
Yeah. So the interesting thing is SQL's been around forever, right? Just the ANSI SQL standard has existed. The execution engine has been the thing that's been particularly played with over the years. So like Snowflake at its core, I mean, Snowflake is effectively Oracle, except without the DBAs deployed in the cloud, and you can manage it on your own. But the execution engine, the thing that actually does a lot of the magic of Snowflake, the clustering and the ability that you can write a query and potentially never have it fail. It can just keep spinning, whereas you do the same thing in something like Spark, it just crashes. Those are dual-edged swords. Mm-hmm. So if you look at something like, we'll look at Databricks. I think Databricks and Spark are it's a great company with a really cool technology. They're investing so heavily in things like Photon, Catalyst, like all of these technologies that are really just made for the purpose of optimizing a query execution. I would even say optimizing, making a query execution more predictable. That's really what I think they're doing. So in terms of the need of tooling, for me, it's for as long as we have people who are going to be authoring queries, we're going to need people who either are educating folks on how to author queries in the most optimal way, or automated tools and solutions that just abstract that problem away. This may be an imperfect comparison, but anyone who worked with the old like C++ memory management things has experienced challenges of memory leaks forever. So you knowing when to like malloc or like deallocate memory is like really, really hard. And so people built layers on top of that. Java became one of the predominant technologies. And then we have like G1 garbage collection, all of these new ways of actually abstracting that problem away. So what I see us doing, or this space in particular, we'll add it's just adding a layer of abstraction that handles the complexity of otherwise having to optimize low-level SQL code based on table semantics or query semantics.
Yeah. So
I have a question actually, and this is for you, Vinoo, and Kostas as well, because I know that you've looked at some of these tools. One interesting dynamic, just to dig in a little bit deeper on some of the tools that allow an end user to actually drive up compute. One interesting dynamic around that is that because those tools can offload compute to Snowflake, it doesn't have to be like a first order concern for the people building those products, right? And so in some ways, you can create a user experience that is amazing, that has the double-edged sword of, okay, well, this is enabling a lot more people to do a lot more things, but it's creating a huge, bill on the back end because you're just hammering compute. How do you see those products managing that? Right. I mean, because that's in my mind, a non-trivial component of your product is sort of the optimization, right? I mean, there's literally entire companies obviously built around query optimization. Of course, I mean, obviously that's Exhibit A with Bluesky, but I'd love to hear your thoughts on that. Like, how do you see those products managing that?
Kostas, do you want to go first, or happy to also?
Yeah, I can. I mean, I have, and that's like also like what I wanted to ask you. Is like, okay, traditionally, let's say the database system has like the query optimizer, right? Like, so you have, let's say, a piece of the technology that is one way or another responsible to go out there and make the best possible choices to execute the query in the best possible way. Obviously, that's a really hard problem. It will never be like completely solved, blah, 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 like all that stuff. But at least you have access to that. Like traditionally, the DBA, like that was like the role of the DBA, right? Like when things starts going wrong, I can use the query optimizer, the planner, like the explain commands, blah, 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 like all that stuff to see what's going wrong and like figure out ways to manually optimize things. When we put like so many layers of abstraction in between, and I'm talking like specifically for things like Looker, like and BI tools where you also have languages that you use to model the data, and there's another piece of software there that takes the data model definition and does whatever it wants to do. The user is like, how do you even like try to tackle this problem, right? Like a query that is generated by Looker that then is optimized by the query optimizer and then turns into a plan and just get executed. How do you even like figure this out? Like in my mind, at least, like it's really, really hard, right? So how can we, I mean, abstraction is good, but it also adds complexity. So how do you think like we can tackle this problem?
Absolutely. And so I think I'm going to go back to the metaphor of how I think about Snowflake, where any query author, I think of as someone driving a car, and their goal is to get from point A to point B. The way that, or how much gas or how much fuel they consume on that journey doesn't just depend on their ability to become the best driver in the world. It depends on so many things: the kind of car they're driving, the environment they're driving in, who else is on the road. And the kind of parallel here is, if I were to say a warehouse in Snowflake, so logical grouping of compute cluster is the car, the optimal route selection or the optimal like gas consumption to get to that end route depends not only on the person, but also on the car. The best driver in the world can still use a bunch of gas driving a Hummer to their place of wherever they want to go. It's kind of the same thing. If I'm authoring a query and my query optimizer is particularly amazing, it's done everything perfectly, That's only a part of the equation. The second part is, where do I choose to execute that query? Am I bin packed with other like incredibly computationally expensive queries, so I'm going to actually slow down and I can't scale up that much? Am I going to be able to have any kind of data locality depending on the technology that I'm using at that point? So all of these come together to, even if the query is written in the most basic query, like select star from this table, there's still so many other elements that are involved in my query execution. So when I say the level of abstraction, I also mean, if we are able to, like, we could train every driver to drive optimally, and even in that situation, all these external factors could throw things for a loop. So what I really mean is, how do I augment that driver, either by extending what the query optimization can do, but also by adding contextual information around street conditions or the road conditions, meaning in Snowflake terminology, like what other queries are being executed, the car, like the size of my warehouse that I have, the number of clusters that I'm scaling up and down. So abstracting that entire problem space away, such that a user is executing an individual query, doesn't have to worry about that, is incredibly powerful. And let me make this a little more concrete. If I'm doing, so Snowflake has had a very interesting thing with this terminology of warehouse. A warehouse doesn't mean anything. It's just like a logical collection of EC2 instances. And so how people actually use or name these warehouses really changes from organization to organization. If people use Looker, their setup instructions say Looker warehouse. Or if they're a little bit more detailed about this, they'll say Looker extra small warehouse, extra large warehouse. But the challenge is, the logical grouping is dependent on the product, not the actual workload of that individual like technology. So if Looker is actually coming in every day and firing a query once every 24 hours that happens to execute on this massively extra large warehouse that has a very high auto suspend, I'm going to be spending a lot of money on that one query. It may even be over-spec'd. So all of these problems coming together, and the contextual information is really how I think about solving this. Instead of a layer of abstraction on top of just the query, it's on top of the data cloud as a whole.
That's very interesting. And like, I want to add like another dimension to this problem, and I want to ask you specifically, because you have also like worked in like in the financial sector. So like how things, how people get motivated to optimize based on like, like the profit that we can have, the alpha that we can generate at the end, right? We all strive like for this alpha at the end. So, and I keep like remembering like cases, for example, like BigQuery, right? There was like this case where you could use like select star limit 10, right? So you would expect that the query agent would just like read 10 values and return them. No, it would go and like actually scan the whole data set and then return just 10. But at the same time, that's how BigQuery's like pricing is based on like how much data it reads during the operation, right? So there's like a lot of like motivation there, like to actually do that, because that's like how the product can make more money, right? And especially like in consumption-based models, I think this is like a very like strong drive to, let's say, guide how like the engineering teams there, or like the product teams like in Snowflake or whatever company there, will make like certain choices. So how important do you think, like outside of the technology itself, like the abstractions that we put there, are also like these other factors, like the pricing models that the companies have, or like, I don't know, like the contracts and like the business side of things, like how much also affect at the end how much it will cost us, and how we should optimize at the end the workloads that we have?
It's a great question. I think one of the really interesting things about how I appreciate Bluesky approaching this, normally people would think, and it's entirely understandable, Snowflake must hate us, right? Snowflake is like, you are taking all of our money away, and it's causing a bunch of issues. So this has been completely opposite from Snowflake's actual reaction. Bluesky is actually a Snowflake partner, which is super interesting if you think about it. And I think a lot of this goes back to, Snowflake's a consumption-based model, a consumption-based pricing model. So arguably, you can look at it and say, they want you to spend as much as possible to pay them as much as possible. But there's a danger underlying this. It's almost like looking at the finance side. If you put all of your stock in one basket, or all of your money in one stock, it's generally very high risk. And so I think Snowflake recognizes that problem. And for them, this optimal deploying of capital has a multifaceted benefit. First, they have solutions architects who kind of function like oracles, DBAs, but they have solutions architects who are really interested in helping companies grow their data cloud in a responsible way. And I think that's incredibly powerful, because Snowflake realizes if I'm spending my entire compute budget on this one poorly written ETL job, there's no way I'm going to explore any other pieces of technology in the Snowflake ecosystem. Whereas if I can instead say, I've optimized this one query, maybe you try a new BI problem or a new business problem or like business venture with this compute money that you've now saved, you're actually further entrenched in the Snowflake ecosystem. So diversifying the workloads, like diversifying your investment, is actually really beneficial. And I actually think that's one of the best things. I think is a discovery Amazon had as well, where even back in the startup that I was at previously, we would focus on, well, if they gave us compute credits or some way of offsetting spend with private pricing, I'm going to take that money and use like Macy or like Redshift and try something completely new. So from the consumption-based pricing model perspective, I actually think a diversified investment is better for the data clouds. And so even having their solutions architects potentially at some point use Bluesky and say, here are the areas we can cut costs, or here's areas we can redeploy capital, is incredibly powerful. I mean, Eric, one thing to your previous question, building these data apps and almost Snowflake is now this like API, right? It's almost like I forget who called it this on LinkedIn somewhere, but they were saying Snowflake's building their own like Apple App Store, where you can build all these data apps backed by Snowflake. And I think it's a really great characterization, because it actually shows that Snowflake is now handling the back-end computation of all of these tools and technologies, and enabling people higher in the stack to generate business value who ordinarily wouldn't be able to do as much work given their lack of experience building some of these technical products. So it's kind of the same thing. If I am Snowflake, I'm not necessarily interested in just optimizing as much compute out of this one app developer, because it means that they can't spend money building, refining, doing other things. So actually running those optimizations behind the scenes, or deploying a tool that can help these folks who are creating data apps like grow and scale, I think is really powerful. And one example I will give, given that they are public, Houseware just won Snowflake's startup challenge a few months ago. And these guys are an awesome team. Like they're building really cool products. I'm not an investor, so I'm but I think they're actually really cool. And so one of the things that they're doing is helping people build these data apps, and being able to build a data app. If you're a small company and just seed stage company, can have all the technology, but be terrified of that big compute bill from some user accidentally running you up. So it's the guardrails around safe compute as well that I think are really powerful.
Yeah, that makes total sense. And one last question from me before I hand it back to Eric. Is Bluesky right now working only over Snowflake, or you support also other data cloud solutions?
So the irony of me right now is I actually didn't know anything about Snowflake till I started working at Bluesky. My experience is fairly heavily Spark and Databricks. For right now, we're focused on Snowflake for two reasons. First, Snowflake is it's a big dominant player in the ecosystem, and I think there's a lot of opportunity in Snowflake in particular. Just from a configuration or query perspective, there's a lot we can do, especially with also SQL. So right now we're focused on Snowflake, but that will almost certainly change as time goes on.
So do you see there more opportunities in systems similar to Snowflake, or also in systems that are more like Spark with because the reason I'm saying that is because like as a computation models are like very different, right? Like very different types of deployments, different teams that are involved. So how do you see like the difference there between like a system like BigQuery or Snowflake or Redshift, and then systems that are more like Athena or BMR and Spark or Databricks? How do you see the difference there?
It's a good question. So I want to say, like, taking a step from back from the perspective of just Snowflake, going to Blue Sky, I always sound like a broken record, but it's really about this efficient deployment of capital, right?
Mm-hmm.
So I would not necessarily say, I mean, this is great, right? If we can optimize someone's spend, that's awesome. But I wouldn't say my goal is to go into a customer and like bring their Snowflake spend necessarily like as down as like humanly possible. My goal is instead to have them effectively deploy their capital. So if they have a bunch of failed queries or they're not using certain BI tools, like that's actually what I'm trying to address, not necessarily just like even negotiating their price down or something. So I think when I look at something like Spark or Databricks, the number of levers that you have makes that problem like an n-dimensional problem. In Snowflake, for example, I don't ask to set like Spark's driver memory or Spark's executor memory. I execute the query and I have some t-shirt size, warehouse size of how often or how optimally it's going to run. But it really depends on like Snowflake to execute that completely independently. So I think when we move out of Snowflake and move to other technologies, I mean, BigQuery doesn't have a lot of these knobs, neither does Redshift. The dimensionality of how many variables we have to tune does become more and more complicated. And our goal is really to look from an organization or like team-wide perspective, not necessarily like this query is slow, let me optimize this individual query. It's really across the organization, here's what you're trying to do. Let me instead help you optimize that. And I'll give you an example that may be interesting for some of the listeners. Incremental pipelines we're seeing all over the place now. So a table that's appending over and over and over. And oftentimes, because businesses are moving so quickly, we've noticed more than a handful of cases where an incremental pipe, like a table is being incrementally appended to, and the downstream consumers of that table still do a full linear scan of all of the table without actually looking at the diffs. And that's actually a really hard problem to identify without a tool that's actively looking for that as like a best practice. And so the dimensions that we can go, or the areas we can expand in Snowflake itself, actually lead themselves to saying, given the multidimensional problem in Databricks and other places, it's actually almost easier and more focused for us to focus on optimizing this one sole area. I mean, I will say this, even being very knowledgeable in Spark, like leading Palantir's Spark team, I don't know how that dimensionality is going to make it easier or hard for us. It could be a really challenging space, or it could be something where we can apply similar principles.
Absolutely. Makes a little sense. All right, so Eric, all yours.
Okay, I want to return to the car analogy as we get close to the end of our time. So one interesting thing, the car analogy with the driver is really helpful, right? Because you have sort of training, a driver trained to operate the vehicle in a resource efficient way. And then the vehicle, to your point, has a huge amount to do with it. And I'm gonna really extend the analogy probably to the point of breaking now to make my point and formulate my question. But if you think about this, I was actually thinking about this the other day because I was driving a car from the 80s that's really old, and you can basically watch the gas gauge go down while you're driving. I think it gets like 8 miles to the gallon or something, and then and also like it's not very fast. So if you like push the car really hard, you're getting like a lot of physical feedback that as a driver that tells you like, hey, you are definitely like using a lot of fuel here. And the car you're driving, it's like really loud and you can see the gas gauge going down, right? So you're not only getting feedback on your own driving, but you're also getting feedback, from the vehicle itself. Then if you sort of look at the modern version of that, right? Like you get in a Prius, that's like a hybrid vehicle, and it will give you real-time feedback on the economy of your driving style, right? And even like the efficiency of the vehicle itself and sort of conserving resources. So again, I'm drawing the analogy out a little bit about that, but like, if you think about executing a query in Snowflake, just in the raw SQL editor, you have like the little time counter, and that's like, that is basically your only physical feedback.
Yeah.
And then if you have a data app on top of that, where you're doing something that doesn't give you any physical feedback, it creates this weird dynamic where it's hard as a user to actually get the information that you need in order to optimize while you're doing your job. And I just love to hear your thoughts on like that as part of this problem set. I mean, I know that Bluesky comes in and helps, and you talked about like, okay, do we have a completely automated solution? But it is interesting. I mean, to your point, like I don't believe that there's, you know, malicious, like we're going to obscure all this so that our NDR is crazy, right? I mean, you know, it's not like they have to have a balanced approach to that. But there is actually not a lot of feedback that helps you sort of, while you're doing the actual work itself, adjust what you're doing to account for resource usage.
Yeah. So I had one of the customers ask me maybe a month ago, 2 months ago now, Vinoo, why don't you just build a SQL query linter that just gives you the red Microsoft Word squiggly lines that says this is not optimal. And honestly, it's not a bad idea. The reason that I think this is a challenging problem is because in your Prius or in whatever car, you have that one dimension. You have, I'd argue the brake and the gas are two sides of the same coin.
Yeah.
Like you can not slam the brake as aggressively, or you can, you know, slam put gas into it. The challenge is with that as your only lever, actually the problem space of what you can do to fix whatever is being fed on the dashboard is much smaller.
Yep.
When I say, hey, this query is like not being run optimally, or if I even said you're doing a linear scan over this data set, the amount of knowledge and expertise it takes to figure out how to solve that problem in an optimal way, it's actually pretty massive. And even if I were to say something like, I mean, we'll use like Java as like garbage collection, right? I could just say in like C++, like you've allocated this thing, my IDE is saying you didn't, you know, destroy it properly somewhere else in the code. Well, those are like great during like effectively like the product runtime. But when they have external dependencies not in the same file, it becomes a really complicated, almost intractable problem. So knowing what to do is the second step, and it's not always easy. Even for like really experienced query authors, like we actually, like I'm our like deployment lead. So when I go to customers, I actually use Bluesky, and I will say, here's areas that I think you can do optimization. But for me, it's still like, let me actually introspect your query. Let me understand the table, not just schema, but like attributes at a fundamental level. All of that effectively have to be surfaced to the point that you can tell like a nice story around what needs to happen. And that's almost why, and rather than just kind of lint in Java and say, here's all the things you can do to better optimize your memory, let's just build a garbage collection tool. Let's just like handle that for you. Yep. So that's kind of our end state. Like, let's just handle some of these challenges for you. And actually, the one additional dimension is some of these challenges you may not even understand. Like in a multi-tenant JVM, like if I have two things running and I have one like service that is like thrashing the hard drive of whatever box it's running on, me as the second service may have no idea why my job is so slow or being queued or IO is as bad as it is.
If I had to summarize that, it would be, you as a driver like shouldn't have to worry about all of these various inputs because it's a much bigger problem than like gas pedal and brake pedal.
Exactly.
Like you should just be able to focus on driving.
Exactly. And I think one of the things Snowflake has done is Snowflake is actually, I don't know if people think about them this way, but they're a giant multi-tenant system. So everyone can share data with everyone else. Everyone's like executing queries in the same, like technically the same AWS or GCP infrastructure as everyone else. So you're really part of this massive cluster that's doing all this computation that can actually affect a lot around whether or not you're getting your query surfaced and run in the exact same time every single time.
Yep. All right. Well, we're close to the buzzer here. So one more quick question for you, and this is advice for our listeners. For anyone listening who's thinking, maybe they don't have a huge Snowflake bill, but this has gotten their wheels turning on, like I wonder what, if anything, is super inefficient in, in the way that we're executing stuff on Snowflake. Where would you have them start looking? Like, where's the best place to start doing that investigation?
I honestly think one of the so the first thing I would say is Bluesky's team is incredibly knowledgeable in this. This is not just me like giving you a sales thing of saying, come talk to us, but finding people that have a lot of expertise in this space is actually really hard. Specifically because when they develop that expertise, they either have a lot of contextual information, like people at big Snowflake consuming companies know about their own unique patterns, but they don't necessarily see the like swath of other ways Snowflake is being used. So I would say like you can reach out to the Bluesky team. The other thing I would do is there's a lot of like Snowflake's The Definitive Guide just came out, and there's a lot of like great material in there. There's blog posts, and there's a lot of sessions like this, like really people who are spending time in the space who kind of share like tidbits of best practices, like the order by or the auto suspend stuff that we discussed. There's a lot of information. We have Bluesky also has a blog where we're slowly creating more and more content. But the main thing I would really do is honestly is experiment, like try some of this stuff out. You can do it, and Snowflake has made it so easy just to try these queries in a smaller capability or spin up even a test instance. So actually playing with the tools and technologies, I think is pretty powerful.
So helpful. Vinoo, this has been such a great episode. I learned a ton. The analogy was, the multiple analogies were great. So thank you so much for spending some time with us.
Absolutely. Thank you both so much. It's been awesome being here, and glad we got a chance to chat. So really appreciate the time and hope this was helpful. Welcome to the Data Stack Show prequel, where we give you a preview of the show that we just recorded. Kostas, this was a really interesting one. And I'm going to actually bring up something that's kind of a teaser, but the car analogy to me was super interesting, where the driver is someone writing a SQL query, and the car is all of the other variables within Snowflake that contribute to the sort of conditions for performance of that SQL query. And Vinoo from Bluesky walked us through that. Tell me, did you think that was a good analogy, a helpful analogy?
Yeah. I think it was great. I think it's really difficult for anyone like to grasp, let's say, the complexity of this infrastructure and like how much it affects, let's say, the organization. Because if you think about like data in a company, something that's used like by pretty much everyone, this happens like through the data infrastructure that you have. And like it's really hard like to optimize it or like figure out like what optimization means at the end, like who you optimize for, and like how is the SLA like defined, what is cost, what is performance, and there are like so many levers there, which like at the end, like makes total sense that you have products at the end like Bluesky that they do like exactly that. So, and I have a feeling we will hear like more and more about like this kind of like products in the future. So I would recommend to everyone like to listen to this episode. It's going to be like super useful for anyone who's working and like maintaining data infrastructure.
I agree. Okay, here's another really important question. When you open Snowflake and start writing SQL, do you feel like a competent driver that is keeping the roads safe?
Do I mean, I don't know. Like, what kind of car do you think you're driving? Is it more like a Ferrari or like it's more like a Toyota? I don't know. Like, what's your feeling?
Does that impact your how safe of a driver you are?
I mean, okay, like you don't always optimize for safety, right? There are times you optimize like for fun.
What is that in Snowflake? A Ferrari is like an XL and a Toyota is like an X small.
Probably, yeah. Like a Prius is probably extra small. The 5XL thing, probably, yeah, I don't know. Like it's the Bugatti or
That's a
something.
jet. That's a G6.
That's a G6, yeah. Like
Yeah.
probably you need the same amount of money to operate.
All right. Well, this is going to be a great episode because Kostas is doing the equivalent of flying a G6 when he opens up the SQL query editor in Snowflake. So definitely check this episode out, and we will catch you on the next one.